Assalamualaikum warahmatullahi wabarakatuh. Today we are going to conduct lab 2, which is identifying the master cylinder and the reservoir. Here is a close overview of the brake system, which is master cylinder and the brake booster. So here we are disconnecting the brake line hose from the master cylinder and the brake booster. So the master cylinder is successfully extracted from the brake hose and also extracted from the brake booster. So this is the view of the master cylinder. We can see that the master cylinder is well maintained. The physical condition is okay and no dents and is in good condition. Here we are extracting the pin from the chamber of the master cylinder so that we can extract the secondary and primary piston. In here you can see that we are trying to first extract the primary piston. So we need to use a bit of force and also a screwdriver to pile inside the chamber so that we can force the primary piston to go out. We use WD-40 to loop inside the chamber of the reserve tank so that it will be more easier to remove the pistons. After a few trials and more lubrication, we finally managed to get the primary piston to come out from the chamber. This is how the primary piston looks like. We can see in the picture, the spring is quite rusty, but overall it is still in good condition to use. Moving forward, we are trying to extract the secondary piston, which is located underneath the primary piston. Using the same method, which is piling a screwdriver on top of it and also adding more lubrication, the spring seems to be quite difficult to move. This is the overview of both the secondary and also the primary piston. Both pistons are still in good condition and are still usable. Here we are trying to take an inside view of the chamber of the master cylinder. The inside chamber of the master cylinder has no scratches or dents identified, not that we can see, and we can assume that the master cylinder, the chamber is in good condition. Next step, we are taking a look inside the reserve tank oil cap. Inside the oil cap there's a diaphragm and we will check the rubber if it's still flexible or not. So in this situation, the rubber is still flexible and in good condition. Before we assemble back the secondary and primary piston, we must use first a sandpaper to smoothen the surface inside the chamber and use a rubber loop to lubricate the inside of the chamber. Assemble back the master cylinder in order of when we first disassemble it, starting with the secondary piston, the primary piston, and finally the pin. Next up, we are going to check the brake booster. From the first lab, we have identified that the brake booster amplifies the foot pressure to use in braking. From the outside, we can see that the brake booster has not been damaged or any dent and is in good condition. Moving on, we are going to calculate the distance travel of the push rod inside the brake booster when the brake pedal is not being pressed. So we are going to calculate its initial position using a vernier caliper with a digital meter for precise measurement. Next, repeat the same procedure as before, but with the brake pedal being pressed. Assalamualaikum warahmatullahi wabarakatuh. Today, our group will present about the latest lab that we done, which is lab 2, master cylinder inspection, removal, and refitting. Our group consists of 6 people. So first, when we see the master cylinder, we were first made to identify the master cylinder part name. So in number 1 is the brake fluid reservoir. Number 2, the reservoir cap. Number 3, reservoir tank. Number 4, diaphragm. Number 5, reservoir clip. Number 6, the control valve. Number 7, stop pin vent port. Number 8, reservoir housing. Number 9, reservoir grommet. Number 10, stop pin replenishing port. Number 11, O-ring. Number 12, primary piston. Number 13, secondary piston. And number 14, master cylinder body. Thank you.
Next, the condition of the master cylinder. So for the inner surface of master cylinder, the picture is here. The condition is no scratch or dent detect, in good condition. And then the primary and the secondary. The spring are rusty but still usable, in good condition. Next is diaphragm. The rubber is still elastic and no sign of deterioration, in good condition. Brake booster, no physical damage seen, in good condition. And last, O-ring, in good condition. Next, inspection. Push rod end. Before it, we take the measuring caliper to measure it. Before press the brake is 28.64 millimeter. After press the brake is 56.62 millimeter. So next question and answer.
Okay, based on your finding, what is the effect of push rod and length to the brake performance? Okay, first, the brake booster pin, also known as brake push rod, work as you press the brake pedal with your foot. The booster pin extend into a piston in the master cylinder to initiate the braking process. If the push rod depth is too long, there will be a delay from the time your foot press the brake pedal until the brake engage, causing the soft brake pedal. If the push rod depth is set too short, less amount of foot pressure needed to initiate braking. A suitable example is braking of Honda Civic FC model. Okay, next.
Okay, for the name type of brake oil used for your car, can different type of brake oil be used and why? So I will explain about this part. My car is a Pro 2 kancil. The brake oil suggested by the manufacturer is a DOT 3 brake oil. DOT stands for Department of Transportation. The DOT place regulation regarding specification for brake fluid to be used in automobile. This is to ensure a standard quality of product for everyone's safety. Never use DOT 5 fluid in a vehicle that use DOT 3 or DOT 4. You can use DOT 4 in a car that uses DOT 3 but not vice versa. This due to DOT 3 is manufactured for daily everyday use while DOT 4 is used for vehicles that do a lot of mountain driving, high speed braking or trailer towing. The higher boiling point prevents the brake fluid from boiling when the brakes are used excessively. Next.
So, name hydraulic tubes that connected to master cylinder and where all tubes are connected. So the hydraulic system function and perform tasks through using a fluid that is pressurized. So hydraulic tubes that connect to master cylinder are the tube that travel to the brake caliper of each wheel of a vehicle. The tubes are called brake lines, and many components are involved in making sure that the vehicle can brake properly. The power of liquid fuel in hydraulic is significant, and as a result, hydraulic are commonly used in heavy equipment. Next. So the function of diaphragm. The pressure on the diaphragm forces it forward, supplying pressure on the master cylinder piston. Hydraulic booster system usually tap into the power steering pump pressure and use this power to augment pressure to the master cylinder.
Mute.
Okay, as a conclusion, we could understand
the component of the master cylinder and also its function over the entire brake system. Our group members can inspect the condition of master cylinder assemble with precision and identify its overall condition. The parts of master cylinder can also be replaced by our group members under the guidance of the assigned lab assistant. We can now name all the parts of the master cylinder correctly.